Okay, so good day everyone. In this video, we are going to discuss the October-November 2024 paper 1-1. Let's start with question number 1. Okay, in the expansion of this particular bracket with power 4, where k is a positive constant. So I think this is important information, yeah? Positive constant for the k. The term independent of x is equals to 150. So independent of x means that the term with x power 0. That means no x, okay, it is fully a number, okay, without the x. So it should be x power 0 is equals to 150. They want us to find the value of k, and after that, determine the coefficient of x squared in the expansion. So there are two parts for this question. The first part is we are going to find the k first. All right, so we are having this bracket with a power 4. So it actually involves binomial expansion. Right, so for binomial expansion, what should we use? There's a general formula when you want to expand the general term in the binomial expansion, where it is kx plus 2 over x squared, 2 over x power 4. Maybe I should write it out in this way first. A plus b power n. The general formula is for any particular term, so it can be NCR, a power n minus r, then b power r. So this is generally what we have. Okay, this is the formula that you can use for any particular expansion, binomial expansion with a bracket, okay, a bracket with a power n outside lah. Right, and now we are going to decide what is the correct r that we need to have to get the term that is independent of x. What do we have in our bracket is we are having kx as a first term in the bracket and also 2 over x as a second term, power 4. Okay, so by right you should have 4c something, then kx power something, then 2 over x power something. So the 2 over x should be power r, and then kx should be power 4 minus r. And we need to decide the r ourselves, right? Okay, so usually for me, I will just try and error a little bit. Okay, we should know that the total power for first and second term, the total power for this first term and also the second term should be equals to 4. Should be equals to the n. Okay, so by right you should have either 3, 1, okay, or maybe you can have something like 1, 3, so that 1 plus 3 or 3 plus 1 equals to 4. So you need to do a little bit of try and error here. And since we are interested to get the term independent of x, which is x power 0, right? So to get x power 0, I know that the bracket, the power for the x here and the power for 1 over x should be the same. Which also means that I will have 2 and 2 here, right? Okay, because when you're having this one, after you expand it, you will have 1 over x power 2. Then when you expand this particular bracket, you are also having x power 2. So x power 2 divided by x power 2, you get something that is independent of x. And you double check the power, 2 plus 2 equals to n, 4, which is a valid pair of power. Alright, then here you should know that it's 4CR, therefore you put it as a 2. Okay, and after that, you try to expand everything on the right hand side. So when I try to expand everything on the right hand side, 4c2 times k squared times x, you need to make sure that you expand all the power, yeah? Okay, put all the power into the term here, and if you simplify it, you should get 24k squared. And they say this 24k squared is the independent of x, is equals to 150. It is provided in the question. Okay, so we do a little bit of simplification. We are having 25 over 4. And if you simplify further, you will have 5 over 2. We'll ignore the negative constant. When you take square root, you have to consider both positive and negative, right? Okay, but I think the question already mentioned very clearly that it is a positive constant for the k. Therefore, we only accept the positive value for the k. Alright, so we done the first part. Already successfully get a value for k, and now we want to determine the coefficient of x squared. So same thing happen here. To get the coefficient of x squared, we need to do a little bit of trial and error as well. Okay, right, so let us start. So we are having now our k is 5 over 2 by what we calculated just now. So 5 over 2x, then plus 2 over x power 4. So I have to ask myself, 4c something, a number that I need to decide later. Then I'm having 5x over 2 power something, power 4 minus r. And then we are having 2 over x power r. And we need to decide what's the value for r here. Then for our question, they want us to find out the coefficient of x squared. So to get x squared, maybe I can have x power 3 here and then 1 over x here, so that I can have something with x squared, right? And if you try to have a look here, if let's say I'm having 3 here, and also this one is 1 over x power 1, then the total of the power is equals to 4, which is the n in our question. So that means these two power are the valid number lah. Okay, so I will put the r equals to 1. So 4 minus 1, I get a 3. Okay, so 4 minus 1, I get a 3. And then 2 over x, I get a 1. Then this is power 1 as well. Right? Yeah, then after that, you try to expand everything also and simplify them very carefully. 4c1, you get a 4. Then the second term here, 5x over 2 power 3. By right, you should have 125x power 3 divided by 8. Then for the last bracket, I have 2 over x. Okay, so when you simplify it further, you'll be having 125x squared. Okay, and after that, for this question, they're asking for coefficient, yeah, coefficient of x squared. Therefore, you need to rewrite again what is the number in front of the x squared. They are interested for the coefficient, not the whole term. So the coefficient of x squared should be 125. Okay, yeah, so this is how we solve the question number. Alright, so let's have a look for question number 2. We are giving a curve and then it has a stationary point at this particular coordinate, yeah, negative 3 and b. They want us to find the values of constant a and b. Alright, so highlight the keyword stationary point. When we are having anything with stationary point, right, basically you have to link it with the differentiation, where at any particular stationary point, dy dx should be equals to 0. Because at stationary point, right, the tangent is a horizontal line, where the gradient of tangent should be equals to 0, and therefore dy dx equals to 0. Okay, so we need to try to use this information, alright, try to use this concept and solve the question. So we'll start from our y first. I'm having y equals to x squared, then minus a. I will bring up the x become x power negative 1, so that it is easier for me to do the differentiation. Then let's discuss about the differentiation here. So I want to find the dy dx. So to find the dy dx for x power 2, for the power you put in front, copy the x power minus 1 become a 1. Okay, then negative a is a constant, I just copy. For the x power negative 1, I bring the bracket in front, become negative 1. Copy the x, bracket, power minus 1. Negative 1 minus 1 become negative 2. Okay, so if I try to simplify this particular term here, I'll be having a over x squared. Okay, so this is what we get after the differentiation, 2x plus a over x squared. This is my dy dx. And for this dy dx, I know that at stationary point, dy dx is equals to 0. Therefore, I will put this equals to 0. Alright, so I will try to get the value for a here. So how can I get the value of a? From the question also, I know that when x equals to negative 3, I will get the stationary point, which means that I will substitute my x as a negative 3 in this equation. Okay, then when I try to simplify them, basically I will be having 6 equals to a over 9. Okay, so by right, if I try to simplify my a, should be equals to 54. Right, so this is how you get the value for a. And how can we get the value of b? Okay, so if you have a look for the b here, basically b is the y coordinate of the stationary point. And that also means that this particular point actually is one of the point lies on the curve. So to find out the value of b, what can we do is we will substitute negative 3 and also b into the curve equation. Right, so again, I'm having y equals to x squared minus a. A is 54 over x. So substitute y equals to b, x is negative 3. Okay, so when you try to simplify everything here by right, you'll be having 9, then plus 54 divided by 3, you get an 18. So from here, you successfully get the b equals to 27. Okay, so this is how we solve question number 2. Question number 3, we are given a diagram. Show a sector of a circle with the center O, where OB and OC is 15, equals to 15. The size of the angle BOC is 2 pi over 5 radians. Okay, then the point A and D, they are lying on the lines OB and OC respectively. Then it is actually an arc of a circle with the center O as well. So from here you can see basically we are having two sectors. One is a big one, which is OBC. Okay, another one is a smaller one, which is OAD. So both of them are actually sector, one big sector and one small sector. Okay, then they are telling us that the shaded region is bounded by the arc AD and BC by the straight line AB and DC. So it is given that the area shaded region is this value. Want us to find out the perimeter of the shaded region and then give the answer in terms of pi. Okay, so from this particular question, right, they give us a lot of information here. Finally, they want us to find the perimeter of the shaded region. Okay, so before you can find the perimeter, maybe we have to use this particular information to get something useful lah. Okay, before we can continue to get the perimeter. So here they are saying that the area of the shaded region is 209 pi over 5. This is what we are given in the question. So maybe you can start from here. We are given that the shaded area is equals to this particular value. Okay, and then if you try to observe this particular question, right, we know that OB, the radius for the big sector is 15, but we actually don't know the radius for a small sector. So maybe I can label this as R, and by using this shaded area, right, I want to try and find out the value for the R. How can I get the shaded area as shown in the question? So you can see that basically we are using the big sector minus a small sector. This is a sector, let's say, okay? So minus a small sector. And you get this particular value. Okay, so the big sector means the sector OBC. The small sector means the sector OAD, right? Okay, so what's the formula for the area of a sector? It should be half R square theta. So for the big sector, it will be half. R square means 15 square. Then the theta is given just now, which is 2 pi over 5. It is given in the question. For the small sector, formula is also the same, half, then R squared. But because we don't know what is the length for OA, right? So I'll just put it as R, so R squared, then 2 pi over 5. And when I take the big sector minus the small sector, I get this answer, 209 pi over 5. I can try to factorize out the half and also 2 pi over 5. Then I have 15 square minus the R squared. Okay, so what's next? I continue to simplify my answer here. Bring the pi over 5 over, become multiply with 5 over pi. Alright, and from here, by right, I should able to get R square equals to 16 eventually. Alright, so I skip a little bit of step here, so you try to figure it out. Alright, so you try to make all the number to the other side and then you simplify. You should get R square equals to 16. So when I try to get the value for R, what should it be? It should be a positive 4. Okay, so please take note that we are going to ignore the negative value for the R because for any radius, right, it should be a positive value. Okay, so we successfully get r equals to 4, but this is not the final answer yet, because for the question, they are asking for what? They're asking for the perimeter of the shaded region. Okay, so let's start and find out the perimeter. Okay, so how can I get the perimeter here? I need to know what is the length for AB. Since we know that OB is 15, right? And OA, just now we got a 4 here. So that means AB. I want to get the length for AB. AB will be 15 minus 4, which is 11. The same length happened for the CD as well, also 15 minus 4, which is also 11. Then what is the length of the arc for BC? So the arc length will be r theta. So what is the r for OB? It should be 15. Theta is 2 pi over 5. Plus the last length is this one, the length of the arc AD. So for AD, the length of radius is r, which is a 4. Then the theta is the same, which is 2 pi over 5. Okay, so from here we try to simplify them. By right, I should be having 22 plus 38 over 5 pi. Okay, we have to leave our answer in terms of pi. It is requested by the question. Okay, so this is basically how we get an answer for the perimeter of the shaded region. So we are now at question number 4. They want us to show that the curve with this particular equation and the line with this equation meet for all the values of the constant k. Right, so we are having a curve. This is a curve equation, and we are having the line equation. We are interested to know how they meet each other. Okay, so basically the meet here tell us that is intersection. We want to figure out how they intersect with each other. Okay, when we try to find out any intersection point, I have to substitute linear equation into the curve equation. And from there, I can find out how they intersect with each other by using the discriminant value. So if let's say I'm having b squared minus 4ac greater or equals to 0, that means they meet at 2 points. Okay, 2 intersection point. If you're having b squared minus 4ac equals to 0, that means they meet each other at 1 point. And if you are getting b squared minus 4ac smaller than 0, then basically they didn't meet each other. So these are the 3 possible cases when you're having a point intersect with a line. Okay, so now they want to show that they meet for all values of the constant k. Meet belongs to these 2 cases. Okay, meet means that they intersect each other, so it belongs to these 2 cases, and we are going to figure out, is it true that this happened for all the value of k? Right, so we'll start here. Okay, so firstly, we'll let the curve as equation number 1. And every time when we want to find the intersection point, right, we'll try to substitute linear equation into the curve equation. So my linear equation is 3x plus y plus a equals to 0. So from here, I get my y equals to negative 3x minus k. Okay, so this is my second equation here, and I will substitute second equation into the first one. Okay, so when I try to substitute the second equation into the first one, okay, this is what I will get. So I'm having x squared minus 3y, sorry, 3x. Then y is negative 3x minus k. Minus 40 equals to 0. Okay, then we can try to expand everything. Okay, then if I rephrase everything in terms of x squared, then followed by x power 1, then followed by the constant, it is equals to 0. Okay, so when we try to find out the intersection point, right, substitute the linear equation into the curve equation, this is what we get. And usually if we want to investigate how the line and the curve intersect with each other, we need to figure out what kind of b squared minus 4ac do I get. So they want us to show, therefore we cannot assume that it is greater or equal to 0 first. When they want us to show, we need to find out the b square minus 4ac, so that the answer that I get is actually belongs to either greater than 0 or equals to 0. Okay, all right. So I will want to find the b square minus 4ac first for this particular equation. So for your information, the coefficient for the x square will be the a, coefficient for the x will be the b, and also the constant term will be the c. Right? So for the b square minus 4ac that I get, you are having b square, which is 3k square minus 4. The value of a is a 10, and the value of 40 is the c is negative 40. Okay, then when you try to expand everything, so you're having 1600. Okay, so let's have a look for this b square minus 4ac here. 9k square plus 1600. Anything, no matter what value of k that you put in, right, it is always positive, because any number with a square is always positive. Multiply with 9 plus 1600 also make the whole expression here is always positive. Okay, therefore you can make a simple conclusion here where this particular phrase is always positive no matter what is the value of k that you substitute in here. So you can write it out for all values of k. Okay, so from here, basically you can see that our b square minus 4ac is always equals to 0, no matter what is the value of k that I put in. Okay, so which fulfills the result lah, okay, that we want to prove. Okay, because when the point and the curve meet, that means it must be having greater than 0 or at least equals to 0. Okay, so from here you can see that it is always equals to it is always greater than 0 for the phrase that we get here for b square minus 4ac. Right, so this is how we solve question number 4. So question number 5, there's an equation of the curve, and given that you have dy dx equals to this whole expression here, find the x coordinate of the point on the curve, which the gradient is 11 over 12. Okay, so highlight the keyword gradient. When you're talking about the gradient of a curve, right, basically it means that the dy dx, and you are having dy dx equals to 11 over 2. So when dy dx equals to 11 over 2, what is the x coordinate for that particular point? Okay, so we'll solve it from here first. Okay, so first of all, I know that my dy dx is given 4x minus 3 square root x plus 1. So I let dy dx equals to 11 over 2. Now try to solve this equation. So before I solve it, right, I want to get rid of the 2 as a denominator. So I multiply the whole equation by using a 2. So I'm having 11 here. 4 times 2, I get 8. 3 times 2, I get 6. And then 1 times 2, I get a 2. Then I rephrase everything to one side. Yeah? So 2 minus 11, I got negative 9. Okay, so I'm not sure whether you're aware or not. This particular equation that we get here, right, it belongs to a quadratic type equation, quadratic form equation. Okay, so if you can observe it, then it will be good. If you can't, then you can let y equals to sub x. If you let the y equals to sub x, right, basically you will see that you get a quadratic equation in terms of y. 8 is 8. X means the square of square root x. Therefore, you're having y squared. Then minus 6y minus 9 equals to 0. So if let's say in case you're not aware that this is a quadratic form equation, then you just try to have a look at, for this particular term, the term in the center, right, you're having a square root. But for the first term, you're having power 1, where the power 1 is double of the square root. Okay, half times 2. Right, so from here, you can actually observe that it is a quadratic form equation. So if you cannot see clearly, then you can just let y equals to sub x. Then from there, you can see clearly it is this quadratic equation that we need to solve. Alright, so for me, because I can see very clearly, therefore I will just directly factorize them from here. Okay, so to factorize it, I will be having 4 sub x with 2 sub x. Then I want to have a 9. So by right, I should have 9. Oh, sorry, I want to have a negative 6 sub x, so I should have negative 3 here. Then this one is a positive 3. Okay, so this is how you factorize it. Again, if let's say you don't know how to factorize it in this form, then you can just change it, become the equation, quadratic equation in terms of y, then you factorize them. But of course, later you need to find back the value of x as a final answer. Okay, right, so let's have a look for this part. Okay, when I try to solve this equation, I'm having sub x equals to negative 3 over 4. Then the second answer is sub x equals to 3 over 2. Okay, then for this part, we'll ignore the answer directly. It is because of when you are having a square root x, right? It actually means that there's a positive in front. So when you're having a positive square root x, it's impossible for you to get a negative 3 over 4. Therefore, for this part, I will continue to solve it. So when I want to take the x, I will need to take square for both sides. And I'm having 9 over 4 as the answer. Okay, so this is the part A. And let's continue to part number B. Okay, for part B, given that the curve passed through the point 4 and 11, find the equation of the curve. So to find the equation of the curve, they want us to find the y. And these are the coordinate. This is the coordinate that passed through the equation. So this coordinate, we can use it to find the constant term later. Right. So now, how can I get the y if we are given dy dx? So from dy dx, to get the y, I need to go through with integration. Okay. So that means to get the y, you need to integrate the dy dx. So what is the dy dx? In the first part, it is 4x minus 3x power half, then plus 1. Therefore, you have to integrate it to get the equation of the y. Right, so we'll go term by term. 4 is a constant, you just copy. X for the power plus 1. 1 plus 1 become a 2 divided by a new power. Okay, minus 3 is a constant, you just copy. Copy the x, power plus 1 become 3 over 2, and you need to divide it by the new power 3 over 2. Okay, when you integrate a constant term 1, you will get the x. Then don't forget about a constant term at last, which is a plus c. Okay, then before you simplify and get the value for the c, what I prefer to do is usually I prefer to simplify everything first. So I'm having 2x squared minus 2x power 3 over 2, then plus x and plus c. Okay, so to get the value of the c, I need to substitute the point 4 and 11 into the equation. So y equals to 11, x is a 4. Okay, so please try to simplify the term here. You will see that basically the c value is equals to negative 9. Therefore, you can rewrite your final answer again for the equation of the curve where y equals to 2x squared minus 2x power 3 over 2 plus x and minus 9. Okay, so basically this is how we solve this question number 5. Question number 6. We are having two circles here, C1 and C2 with this equation. Right, so they want us to find the distance between the center of the circle. Okay, so if I want to find the distance between the center, I need to know what is the coordinate of the center for both circles. Okay, for the first circle here, I already know that the center basically is 9 and also negative 4. Okay, because you let x minus 9 equals to 0, so you get a 9. Y plus 4 equals to 0, you get a negative 4. So this is basically your center. Alright, and after that, if you move the 64 over, become equals to 64. Can be written as 8 squared, which means that your radius for this second circle is equals to 8. This is so far what we can get from this particular circle equation. And to get the distance between the center, right, of course, I need to know what is the center for the first circle here. So how can I get a center from the first circle? Personally, I prefer to complete the square for the equation in terms of x and y. Yeah? So I'm having x squared plus 6x. I group all the x together first. Then y squared minus 10y plus 18 equals to 0. So from here, I will start the completing square process. Okay, so I copy the x first. So to complete the square for this one, you take the 6 divided by 2, which is a 3. So you're having my plus 3 square minus 3 square. Okay, then after that, followed by the y. So I'm having y square minus 10y. Okay, so how can I complete the square for this one? So you take negative 10 divided by 2. So you're having negative 5. So negative 5 square minus negative 5 square. Then copy the constant term plus 18. And it is equals to 0. Okay, so for the next step, you are going to combine the first 3 terms here become one big bracket with a square outside. Okay, then the negative 3 square, you just copy as negative 9. Same thing happened for the y. Combine the first 3 terms become one big bracket, so y minus 5 with a square outside. Then minus negative 5 square is negative 25. Then plus 18. Okay, then we try to simplify everything here. So I'm having x plus 3 square plus y minus 5 square minus 9 minus 25 plus 18. So when you simplify all this value here, you'll get a negative 16. Okay, then I try to rewrite it one more time because from here I want to know, right, what is basically the radius of my first circle here. 16 can be written as 4 squared. Okay, so from here, if you want to know a little bit more about this circle, right, you should know that the center is actually negative 3 and 5. Then the radius is equals to 4. Okay, so let's come back to our question here. They want us to find the distance between the center. So center basically is a point, right? Okay, so they want you to find the distance between these 2 points, this center and also this one. Okay, so can I find the distance between 2 points? Okay, so basically you need to use the formula x1 minus x2 square plus y1 minus y2 square. So x1 is a 9 minus x2 square, so it will become 9 plus 3 square. Okay, then plus y1 minus y2 square. So y1 is negative 4, so minus 5. So you're having negative 4 minus 5, then you square it. Okay, then after that from here, if you try to simplify them, what do you get is square root 144 plus 81. And you get square root 225. Therefore, the distance between the two center of the circle, right, is equals to 15. Okay, yeah, so you need to find the center for the first circle first before you can find out the distance between the two center. Right, then after that, for part number B, now they are talking about the P and Q are the points on C1 and C2 respectively. The distance between P and Q is denoted by D. Find the greatest and least possible values of the D. Okay, so now let's say I'm having a first circle C1. Okay, so I label this as C1. Yeah, and then the C1 from the previous part just now, right? We know that the radius is equals to 4. Then the center is equals to negative 3 and 5. Okay, then after that we are having a C2. So another circle C2. For the C2, I know that the radius is equals to 8. Okay, then the center is equals to 9 and negative 4. Okay, and then now they ask us to find the greatest and least possible values of D. That means the distance between P and Q, where P and Q must be lying on the line, on the circle. Okay, so where can I get the nearest or the shortest distance between P and Q. So if you are aware by right, P and Q should be somewhere here so that it can be the shortest. Okay, or maybe what we want to do is like maybe we try to think about the perpendicular distance between the line and also the sorry, between the point and also the between the 2 point, right, on the circle. All right, so maybe what we can do now is we just try to use our result to help us to find the answer. Okay, if let's say from center to center, right, this is basically 15. Then to get the shortest distance, right, my P and Q should be somewhere here, so that the distance between P and Q is the shortest. Okay, so how I know that this is the shortest distance? It is because of when you are having the line, right, pass through the diameter. Okay, pass through the diameter of the circle, it will be the greatest distance. And the same thing happen if let's say we are having the same line, but we putting the P and Q on the circle itself, this will be the shortest distance. All right, so how can I get the shortest distance if I label it in blue color like this? Okay, so you can, to get the shortest distance, basically you know that you are taking 15, the distance between the two center, minus the radius of circle number 1, and also minus the radius for circle number 2. Okay, so this is how we figure it out. Okay, so let's start. The shortest distance equals to what? Is equals to, originally you're having 15 minus the radius for circle number 1, which is a 4, minus the radius for circle number 2, which is the 8, and you will get the distance, the shortest distance between P and Q should be equals to 3. Okay, then the same thing happens. If they are looking for the longest distance, then what can I do? So for longer distance means that you need to extend the line until it pass through the center, pass through the diameter of the circle, and reach, okay, the circle on the other side. So I put it in green color for this question. So this will be the longest distance. And you are aware that for the longest distance, right, you are taking the distance between the two center at the radius of circle number 1 and also at the radius for circle number 2. This is how we get the longest distance. So longest distance can be written as original value, origin distance between the two center, plus the radius of the first circle, plus the radius of the second circle. So the greatest distance between P and Q should be equals to 27. Okay, yeah, so this is how we solve question number 6. Okay, so let's discuss question 7. We are given a diagram and it is actually part of this particular curve. Then the point A on the curve has a coordinate of 7/2 and 6. They want us to find the equation of tangent to the curve, right? So mainly we focus on equation of tangent for this question. Then give your answer in the form of y equals to mx plus c. Alright, so to find the equation of tangent, when you see this keyword tangent, basically it means that to form the equation, you need gradient and also passing point, right? So the passing point for this particular line will be the coordinate of A, which is 7/2 and 6. Then to find out the gradient of the equation, the gradient of tangent basically equals to dy over dx. And you have to substitute the x coordinate of the particular point that they are interested. Okay? Yeah, so basically this is what we should do for this one, for this question. So first of all, let us start with the differentiation first. So I'm having y equals to, copy the constant, and then I want to bring the bracket up. So I'm having 2x plus 1 power negative 1/3. By right, we are having a cube root here, right? You can see a cube root here. Okay, so when you want to take out the bracket, it will be power negative 1/3. Okay, so first step, I want to find the dy dx. 12 is a constant. I just copy it. I pull the power of the bracket in front, so I'm having negative 1/3. Copy the bracket, power minus 1. So negative 1 over 3 minus 1 become negative 4 over 3. And after that, I differentiate the thing inside the bracket. So when I differentiate the thing inside the bracket, I'm having a 2. Okay, so further simplify this particular expression here. By right, you'll be having negative 8. Okay, then 2x plus 1 power negative 4 over 3. You can break it down. And then you're having a cube root with 2x plus 1 power 4. Okay, so this is the general term in the general term for dy dx. And because for this question, we're interested to find out the equation of tangent on this particular point, 7 over 2 and 6. Therefore, to calculate the gradient of the tangent, you need to substitute 7 over 2 into your dy dx so that you can get the gradient of tangent. So substitute inside, what do you have here? Okay, so substitute the x coordinate, yeah. So you're having 7 over 2, then plus 1 whole thing power 4. Okay, so please do a little bit of calculation. By right, you get the value which is negative half. And you need to know that this negative half means the gradient of tangent. Okay, and now you have when you want to form any equation of straight line, right? Like if you need to form the equation of tangent, you need two important things. You need the gradient of the line, where we already have it. Okay, and you need also the passing point of the line, where we also have it as well, which is the point A. Right, so by using these two information, we can try to figure out and find out the equation of tangent now. Right, so I'm using the general equation y minus y1 equals to mx minus x1. So y minus y1, which is the y coordinate of A, equals to m. M is the gradient, negative half, then x minus x1. So x minus 7 over 2. Okay, and after that, of course, I need to rephrase my equation so that it becomes the pattern y equals to mx plus c. So expand everything, I will be having this one. Simplify the constant term. By right, I will be having plus 31 over 4. So this is in the form of y equals to mx plus c for the equation of tangent for this curve on the point A. Okay, so this is how we solve the part A. And let's have a look for part number B. Okay, so for part B, or it is at the next page. Okay, so for part B, they want us to find the area of the region bounded by the curve, the line x equals to 0, x equals to 7 over 2, and also y equals to 0. Okay, so let's have a look for the diagram again. They want us to find the area bounded by the curve. Okay, bounded by the line x equals to 0 means the vertical line, y-axis. X equals to 7 over 2 means this line, also the vertical line, and then y equals to 0 means the horizontal line, which is the x-axis. So basically, they want us to find out this particular area. When you want to find any area under the graph, you can see that this area is under the graph y, right? When we want to find the area under the graph, we need to involve integration. Okay, so what's the integration that how can I set up? Right, so to integrate and get the area, you need to know where your area start the limit. So your area start at this line, which is x equals to 0. So your lower limit will be a 0. The area end at this particular point of this particular line where x is 7 over 2. So you put 7 over 2. Equation, okay, of your y or of the curve that bound the area, then dx. Okay, so this is how we set up the question. Now you need to know where the limit start or where the area start and where the area end. So basically these two values will form your lower and upper limit for the integration. Alright, okay, so let's continue with the calculation for this one. So I'll copy it and bring it to the next page. Alright, so let's have a look. Okay, so like what I showed you just now, right? This is basically what we should carry out to get the area. Alright, so let's continue with the integration. So 12 is a constant, right? So 12 is a constant. Therefore, I can just copy the constant without doing anything. For the bracket, I will need to copy the bracket. Then I take the power plus 1. So negative 1 over 3 plus 1, you will get 2 over 3. Then you have to divide it by the new power, 2 over 3. Then at the same time, you still need to differentiate the thing inside the bracket. Differentiate 2x plus 1, you get a 2, right? So you have to divide it by 2 as well. And then I have to substitute the upper and lower limit, which is equals to 7 over 2 and also 0. Okay. Before I substitute the upper and lower limit, right, my habit is I prefer to simplify all the constants first. Then only I substitute the value so that my equation doesn't look so complicated later. Alright. Okay, so when I try to simplify all this number, okay, so you're having 4 over 3 at the bottom. So 12 divided by 4 over 3. And you simplify it by right, you will get a value 9. So I will take out the constant 9. Then in the bracket, I left only 2x plus 1 power 2 over 3. Then I need to put in the limit 7 over 2 and also the 0. So I prefer, okay, to take out all the constant and simplify them first before I substitute the value, so that when you substitute, your solution doesn't look so complicated, right? So 9 you just copy. Now I substitute 7 over 2 into the equation, so I'm having 8. 8 power 2 over 3, you'll get a 4. Okay, then after that, minus, substitute 0 into the equation, so you're having a 1. Okay, 1 power 2 over 3, you get a 1. So 4 minus 1, you get a 3. So simplify the answer, your area should be 27. Right, so this is how we solve question number 7. Alright, so now we are at question number 8. It is given that beta is an angle between 90 degree and 180 degree. Okay, so when you see this one, basically you should know that the angle beta belongs to second quadrant, because from 90 to 180, so it belongs to second quadrant, or we call it as acute angle, we will call it as obtuse angle, right? In second quadrant, okay? And now they tell us that sine beta equals to A. They want us to express this particular expression in terms of A. Alright, so before we can find out this expression in terms of A, we need to figure out first, if let's say sine beta equals to A, what will happen to tangent beta and also cos beta. Okay, then after that only we can substitute the value inside, right? Okay, right. Some students will draw the triangle. For me, I will also draw the triangle, but I will draw it out in the second quadrant. Okay, so for second quadrant, this is how my graph look like. And if I want to draw a triangle in the second quadrant, by right, the triangle should be something like this. It is a right angle triangle where you can see that the x value should be a negative value, the y value, the vertical line should be a positive value, and your hypotenuse is always positive value. Okay, and they are telling us that it is the angle between 90 to 180, right? So that means this is your beta. And they tell us that sine beta equals to A. So sine beta equals to A, it means that it is opposite over hypotenuse is equals to A. So for this particular complement angle, right? Okay, the acute angle for this beta, so you'll be having A, okay, then over hypotenuse is a 1. Alright, so according to this particular triangle here, the right angle triangle here, okay, the adjacent length or the x-axis length, the horizontal length should be square root 1 minus a square. It should be 1 square minus a square according to the Pythagoras theorem. And because of the triangle, you can see that it is towards the left hand side, right, for the horizontal line here. By right, you will be having a negative value here. So it is negative square root 1 minus a square. If you want to draw the triangle according to the x and y axis, by right, it should look something like this. Okay, or there's another option where you just try to draw a normal triangle and then you try to figure out the sign, positive and negative sign for the trigo in the second quadrant also can. Alright, so there are a few ways for you to solve it and sort it out lah. Okay, and now I want to find out tangent square beta minus 3 sine beta cos beta. Okay, so tangent square beta basically means tangent beta square. What is the tangent beta from what we can get here? So tangent is opposite over adjacent, which is a divided by this one. So you'll be having a divided by negative square root 1 minus a square. And you need to square the tangent, right? So it will be the whole thing with a square outside. Then minus 3 sine beta, we'll get a a. Okay, it is given in the question directly. And then what is the value for cos beta? So for cos beta, it is the adjacent length, which is this one, negative square root 1 minus a square, divided by the hypotenuse, which is a 1. Okay, then from here, we try to simplify the answer. I'm having a square divided by negative square become positive. So square root square become no more square root. So I'm having 1 minus a square at the denominator. Then for this particular term here, after you simplify it, you should be having 3a, then square root 1 minus a square. And negative become positive. Right. Yeah, so this is how we simplify the particular expression shown in the question. Yeah? Alright. So this is what we have. If I draw the triangle in the second quadrant, okay, just in case, if let's say some students, they are using just a normal triangle to represent and find out the value, then this is how you solve it. And you need to know that beta is obtuse angle. So this is another type of solution you can consider if let's say you don't really like the first method here. Alright, so now if let's say you want to use the other method, that means you need to know at first B is obtuse, sorry, the beta is obtuse angle. Okay, then when you try to draw the triangle, okay, you are still using the information given by them where you're having a beta. So sine beta is A, which is opposite over adjacent. Then the length for the horizontal line will be 1 minus a square square root. So still the same thing. But when they want you to find out the tangent square beta minus 3 sine beta cos beta. Okay, so what you need to do is you try to figure out what's the value for tangent beta. So tangent beta, according to this triangle, it is a divided by square root 1 minus a square. So it will be a divided by square root 1 minus a square. And because I know that B is an obtuse angle where it belongs to second quadrant. So tangent beta, where beta is second quadrant, give you negative value, right? Because in second quadrant, only sign is positive. Therefore, when you want to find tangent beta, you need to put a negative yourself. Alright? And then you have to square the tangent. Then minus 3 sine beta is a A. Then how about for cos beta? So again, cos beta is adjacent over hypotenuse, which is square root 1 minus a square. So same thing happened here because I know that beta is in second quadrant. Therefore, cos in second quadrant is also a negative value. So you have to put a negative by yourself. Alright, so from here, when you simplify it, you will see that the answer that we get basically is still the same. Although the technique is a bit different, but the final answer generally is the same. So we are having square root 1 minus a square. Okay, alright, so this is how we get the answer for part A. Then let's proceed to part B. For part B, they want us to solve this particular equation. You're having sine square, cos square, and also sine theta here. And then the theta is between 0 to 360. Alright, so before you can solve the equation, right, it will be good if we can directly change all the equation with only one type of trigger. As an example, like all the equation, the whole equation here only have sine theta, or the whole equation here only have cos theta, right? Then if I have a look for this equation, I realize that it will be possible for us to change the whole equation become the sine theta, because you can try to use identity that we learned earlier, where sine square plus cos square equals to 1, right? Therefore, cos square theta can be written as 1 minus sine square. So when you substitute this identity in your equation, your whole equation will have everything in sine square. Everything is sine theta. So let's start. Okay, so I'm having sine square theta plus cos square theta equals to 4 sine theta plus 3. Okay, so substitute cos square theta. Oh, sorry, I copied the question wrongly, right? There must be a 2 here. There should be a 2 here. Okay, so cos square theta I substitute by using 1 minus sine square. Now I try to simplify my whole equation. Okay, and next if I try to further simplify it, I'll be having sine square theta plus 4 sine theta plus 1 equals to 0. You try to move everything to one side, okay, and then try to adjust the sign and whatsoever. Then your final equation should look something like this. Okay, alright, then now I want to solve for the equation. To solve for this equation, right, it is a quadratic form equation in terms of sign. Then I try to have a look and see whether am I able to factorize this quadratic equation or not. You realize that we're not able to factorize it. If we're not able to factorize it, to get the sine theta, I have to apply the quadratic formula to find out the sine theta, right? So what's the quadratic formula? Still remember? So to find the x, there's another option for you for quadratic formula is you need to use negative b plus minus square root b square minus 4ac, then divided by 2a. Okay, so we are applying this formula in this quadratic form equation here. So instead of x, we are going to find the sine theta. Right, so substitute the value. Negative b means negative 4 plus minus b squared. So what is the b squared here? B squared should be 16. 4 square, right? So minus 4, a is a 1, c is also a 1. Then divided by 2a, which is divided by 2 times 1. Okay, then by pressing the calculator and help us a little bit, we'll have two answers for sine theta, where the first one is sine theta equals to negative 0.2679491924. And another one will be sine theta equals to also a negative value, which is negative 3.73 something. Okay, so now we need to solve these two equations to get the theta. Okay, let's have a look for this equation first. Sine theta equals to negative 3. The range for the sine theta is between negative 1 until positive 1 only, right? So for any value that's less than negative 1, there will be no solution for the sine theta. Therefore, we can directly ignore this part. Okay, then our theta are mainly coming from this first equation here. Right. Okay, so first of all, I will want to get the basic angle. Every time when I want to get the basic angle, I will press the calculator without the negative sign. So I will have sine inverse, then 0.2679 blah 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 blah. Okay, so by right, your sine inverse should be 15.5. You want to get the acute angle, or I call as basic angle first. Okay, for this particular value. Okay, so after I get the basic angle, only I go through the quadrant and see which quadrant I want to accept the answer. Alright, okay, so I know my basic angle is 15.5, yeah? And let's have a look. We want to have sine theta, which is a negative value. So in which quadrant sine theta will give you a negative value? So it will be in the third and also the fourth quadrant. Okay, right. So how to get the answer for theta in the third quadrant and fourth quadrant? By having the basic angle. For third quadrant, it will be 180 plus the basic angle. This is the third quadrant. For the fourth quadrant, the general formula will be 360 minus the basic angle. Okay, so simplify your theta here. If you didn't do any careless mistake, by right, your answer should be 195.5. Then another one will be 344.5. Okay, so basically, this is how we solve question number 8. Okay, so we are at question number 9 now. We are given this equation and they want us to find the set of values of x when y decrease as x increase. So I had the keyword decrease. So they're asking us when do we have the function decrease? Okay, they want to know the value for x when the function is decreasing. Okay, so when we want to investigate whether the function is decreasing or increasing, we need the differentiation, the dy dx of f prime x. Okay, because the dy dx of f prime x are the gradient of tangent, right? So if the gradient of tangent is positive, means that the graph is going up, which is increasing. So if the dy dx is negative or the gradient of tangent is negative, basically it means that the function is decreasing. Okay, so first we need to find out the differentiation first. So I'm having y equals to 4 plus 5x. Okay, so this is the equation that I have. I need to find out the differentiation, which is dy dx first. Differentiate a 4, I get a 0. For a constant, right, I get a 0. So differentiate 5x, I get a 5. Then differentiate 6x squared. The square you put in front. Okay, the 2 you put in front. So 6 times 2, you get a 12. Copy the x power minus 1, become power 1. So 3 is a power, you bring it forward, okay, you bring it to the front. So 3 times 3, you get a 9. Copy the x, then the original power minus 1 become a 2. Okay, so this is my dy dx. And since they are interested for the value of x when the dy dx is decreasing, therefore we are interested for the dy dx smaller than 0. So negative 9x squared plus 12x plus 5 smaller than 0. This is dy dx, right? Smaller than 0 means less than 0. Okay, when I'm having a negative for the first term, I prefer to make it become positive. Therefore, I will make it become a positive 9x squared minus 12x minus 5. And we are looking for, because we multiply the whole inequality with a negative, therefore you have to change the sign here. Okay, but originally, of course, we are interested for dy dx smaller than 0 1. Okay, so we are changing it become greater than 0 because of I'm changing negative 9x squared become positive 9x squared. Therefore, I multiply the whole equation with a negative sign. And this is the reason why I need to change the sign here. Right? And after that, I will want to factorize them before I can decide the set value of x. Okay, so when I try to factorize them, I should have 3x and 3x. Then I will have 1 and 5. So that I'm having negative 15 plus 3, which is equals to negative 12x. Okay, so after I factorize them, you need to know that there are two critical values here. So the first critical values will be negative 1 over 3. The other one will be positive 5 over 3. So how I get these two values? Basically, it is by solving these two brackets here. So 3x plus 1 equals to 0. So you get negative 1 over 3. So 3x minus 5 equals to 0. Then you get 5 over 3 here. So these are the two critical values. Once you have these two critical values, you can use any method that you like to decide when do you have a decreasing function. Okay, so for me, I'm using number line. Some students might want to use the table of sign. Okay, or some students prefer to sketch the diagram out, whether is it a U shape or N shape also can, right? It doesn't matter one. So for me, I'm using the number line. So I will draw both bracket to the right hand side because both bracket is having a positive x, right? 3x plus 1, 3x minus 5. 3x, 3 is a positive. So 3x plus 1, the 3 here also positive. Therefore, when I want to draw the diagram, the number line, both will be going to the right hand side. Anywhere with the line is having a positive sign. So overall positive times positive, you get a positive. Then positive times negative, you get a negative here. Then negative, negative, you get a positive here. And then to decide the final answer, I need to look at this particular inequality here. We are interested to look for greater than 0. In which part do I have generally greater than 0 means positive? So this part positive, this part means negative, this part means positive, which means I want to accept the x in this part and also this part because both of them are positive sign in these two parts here. So we can just write out the answer. So from here, right, you can see that x smaller than negative 1 over 3, you'll get the whole inequality positive, whole expression positive, right? Then same thing happens here. When x is greater than 5 over 3, your expression will be a positive expression. So this is the set of value for x where the y is increasing. Sorry, is decreasing. Okay? Yeah. Then let's proceed to part number B. Alright, so for part B, and now they give us this linear equation, y equals to 9x plus k is the tangent to the curve. Highlight the keyword tangent. They want us to find the value of k. Alright, so when they're talking about the tangent of the curve, right, I think we did discuss just now. Tangent, generally we're trying to link it with dy dx of the equation, the y equation. Alright, and you know that tangent, the gradient of tangent, basically is equals to dy dx. And again, from this particular equation given, right, they already tell us that this is the equation of the tangent. So from here also, I know that the gradient of this particular line, of the gradient of this tangent is 9x, y equals to mx plus c, right? So the gradient is equals to 9. And I know that dy dx can be equate to 9. And we are going to use this information to solve for the rest of the question. Alright, so let's start. Since I know that, I want to use dy dx equals to 9 to start with my equation, to start this question. I already get my dy dx just now in part A, right? Okay, so in part A, when I get my dy dx, the original equation is something like this: 9x squared negative plus 12x plus 5. And I equate it equals to 9. Alright, then I will try to simplify them and solve. Okay, so if you try to simplify it, you'll be having negative 5 plus 9. Sorry, there's no negative 9, it's plus 9, positive 9. Wait, yeah, let me have a look. Did I do any careless mistake? Maybe I prefer, it will be easier for me to change everything here. So negative 9x squared plus 12x plus 5 minus 9 equals to 0. So I'm having negative 9x squared plus 12x minus 4 equals to 0. Then when I want to make the 9x squared become positive, then it's easier for me to change the whole thing. Okay, alright, then now I want to get the value of x because I want to know at which point they will give me the gradient of tangent equals to 9. And again, from here, right, you basically can try to factorize them again. And since they did tell us that this is a tangent to the curve, that means this particular line touched the curve at one point. Okay, so by right, when you factorize them, right, you should have only one answer, which means that these two brackets should be the same. Okay, by right, it should be the same. So if you can, you double check, yeah. Alright, so if I try to factorize them, I will have 3x minus 2 for both bracket and it equals to 0. Therefore, I know that my x is equals to 2 over 3. Okay, so if I know my x is equals to 2 over 3, right, if I substitute here, it is not enough for me to find the k as well. So I need to know what is the y. So substitute x equals to 2 over 3 into the y equation. So my y equation is y equals to 4, then plus 5x. So 5 times 2 over 3, 6x squared. So 2 over 3 squared minus 3x cubed. So 2 over 3 cubed. Okay, then I'll get my y equation, y value, which is 82 over 9. Okay, so maybe you can double check and see whether you get this answer or not. And since the tangent and the curve meet each other at one point, right? Okay, so that means on this particular point will be 2 over 3 and also 82 over 9. So to get the k in the tangent, equation of the tangent, you can substitute it into the equation of tangent provided here. Then you can get the value of k. Alright? Yeah, then I will substitute it. So y is 82 over 9 equals to 9x. So 9 times 2 over 3 plus k. So from here, just try to simplify a little bit. By right, your k should be 28 over 9. Okay, so this is how we get the value of k in this equation of tangent. Alright, so now we are at question number 10. There's an arithmetic progression with the first term 5. Common difference is the d, where d is greater than 0. That means d is positive. The second, fifth, and 11th term of the arithmetic progression in the order are the first 3 terms of a geometric progression. Find the values of d. Okay, so let's have a look for our arithmetic progression first. Yeah. So the first term is a, where our t1, I will write it as a, as a 5. Okay, a equals to 5. And after that, they are saying that the second term. So the second term, how can I write out the equation for second term here? So for t2 of an arithmetic progression, I can write it out as a plus n minus 1d. N minus 1 means 2 minus 1, which is a 1, and then d. Okay? Then after that, you have fifth. What is the fifth term for arithmetic progression? So a plus n minus 1d, which is 5 plus 4d. Then for the 11th term, it will be a plus n minus 1d. So a plus n minus 1, 11 minus 1, you get a 10. So 10d. So these are the 3 terms, second term, fifth, and also the 11th term in the arithmetic progression. And now they are saying that are the first 3 terms of a geometric progression. So that means these 3 terms here basically belongs to the first 3 terms of geometric progression. So GP. So for the GP, right, this one is the first term. This one is the second term. This one is the third term. Okay, in a geometric progression, yeah? Right. And now, they want us to find the value of D. Okay, so how can I find the value of D if I know that this is the first term, second term, and third term in a geometric progression? Okay, so for geometric progression, we can try to use the idea where it is having the common ratio, right? Okay, so for common ratio means what? Means that your R can be get by using T2 divided by T1 and also T3 divided by T2. So that means the common ratio R can be written as T2 divided by T1 or T3 divided by T2. So I will use this particular information to start our calculation. Alright, so I will start from here. I will let T2 over T1, which is the R, equals to T3 minus T2, which is also the R, right? Okay, so T2, 5 plus 4D, divided by T1, 5 plus D, equals to T3, 5 plus 10D, divided by T2, 5 plus 4D. And if I try to solve this equation, should be no problem for us to get the value of D, right? Okay, so I do a little bit of cross multiplying. And then after that, I can simplify them and solve for the D. Okay, so I'm having 25 here. Okay, so 5 times 4 is 20 times 2, you get 40D plus 16D squared. Same thing happen for the right hand side, expand everything first. then I'm having 10b squared. Okay, so I'm having the quadratic equation in terms of d. Try to simplify them. By right, I'll be having 6d squared. So 40 minus 55. 40 minus 55, I'll have negative 15. Okay, 25 minus 25, I'll get a 0. Okay, so this is what I get after I simplify the whole equation. Right, then I realize that I can take out the factorize out the 3d, so I will be having 2d here. Okay, then minus 5 equals to 0. Okay, then if I try to solve this equation, d is equals to 0, where we should ignore it, because in the question also they already tell us that the d should be greater than 0. Even if the d is equals to 0, we accept we won't get the arithmetic or geometric progression, right? Okay, so we have to ignore d equals to 0. Therefore, the other answer for the d will be 5/2. Alright, so this is how we solve the part A. Let's proceed to part number B. Okay, so for part number B, now they are telling us that sum of the first 77 of an arithmetic progression is denoted by S77. Sum of the first 10 terms of the geometric progression is denoted by G10. They want us to find the value of S77 minus G10. Okay, so let's have a look for AP. Yeah? We are interested to find out S77. So what's the formula? It will be n divided by 2. Okay, so 2a. We need to find out the value of a in arithmetic progression, sorry. And we already know it is a 5 just now, right? So 2a plus n minus 1d. So 77 minus 1, you get 76. And the value of d that we calculate just now is 5/2. Okay, then if you try to simplify this particular term, you'll be having 7700. Okay, and now I want to find out the G10. Before I can find out the G10, okay, so maybe I put a small note here. This one we are using Sn equals to n/2 to a plus n minus 1d. In case you can't remember, you can still refer to the formula booklet. Right? Then for the sum of the first n term in a geometric progression, so basically you should have a, then either 1 minus r power n or r power n minus 1. Both also can, no problem at all. So I'm using 1 minus r power n, then divided by 1 minus r. Okay, so maybe for this particular geometric progression, I need to figure out first what is the first term and also what is the common ratio. Okay, alright, so for the geometric progression, what is the first term? So the first term is basically equals to the second term just now, right? Of arithmetic progression. First term of geometric progression is equals to the 5 plus d. Okay, so I go back and substitute with 5 plus d. 5 plus d. D is 5/2. Okay, so you have 15/2. Then how about the common ratio r? So the common ratio r is you take the second term divided by the first term. So what's the second term here? 5 plus 4d. Okay, so I'm having 5 plus 4d. So 4d is 5/2, then divided by the first term, which is 15/2. Okay, if you don't do any careless mistake here, by right, your common ratio for geometric progression should be 2. Then now, only I start to find out G10. Okay, so A, 15/2. Okay, so this is 15/2. Then 1 minus r power n. So 1 minus r is a 2, power n means power 10. Then divided by 1 minus r. So I'm having 1 minus 2 here. Okay, so you get a value for G10. So G10 will be a fraction which is 15345 divided by 2. Alright, then to get the final answer, they want us to find out S77 minus G10. So just use your answer and minus each other lah. Okay, so 7700 minus 15345. Okay, so if you don't do any careless mistake, by right you will get 55 over 2. Okay, yeah, so this is how we solve question number 10. Alright, and now we are at the last question for this paper. We are given a function f, and it is defined for x, any real number lah, is the element of real number. They want us to express fx in this pattern. So basically this one belongs to completing square form lah. Alright, and state the range of f. Okay, so let's start. When we want to complete the square, we have to make sure that our x squared, coefficient of x squared is a 1. I need to factorize out negative 2 from the x squared. So I'm having x squared here. Then factorize out negative 2 from 6x also. So you're having negative 3x. Okay. Then the original plus 3, I don't touch it because it is not involved in the completing square part. Right. Okay, so after I factorize out the negative 2, I will get x squared minus 3x. So I try to plus something square minus something square to complete square it. So what's the something here? So you will take the coefficient of x, which is negative 3 divided by 2. So I'm having negative 3 divided by 2. This one also the same. Negative 3 divided by 2, then square. Okay, so the next step is you are going to combine the first 3 terms into one big bracket with a square outside. So if you complete square this one, you will be having x minus 3 over 2 square. Then the original negative 3 over 2 square, you expand it, become 3 square is a 9, 2 square is a 4. So this is what we have inside the bracket. Okay, then plus 3. The plus 3 is outside the bracket. Okay, then next one, you try to multiply negative 2 in the bracket and also to the second term. And you should be having this. Okay, then further simplify it, you'll be having 15 over 2 minus 2, then x minus 3 over 2 square. Okay, so this is how we complete the square for this particular function. And after that, they ask us to state the range of f. So for what we know, right, if we try to complete the square, basically this pattern already gives us the stationary point, the coordinate of the stationary point. Alright, so from here, you know that x is equals to 3 over 2. And 15 over 2 will be the y. So I know this is the coordinate of the stationary point, and I want to decide whether is this a maximum point or minimum point. So you look at this one, you're having a negative 2, right, for the x squared, for the bracket with the x. Okay, so that means if you expand everything, your x squared is having a negative value, which is negative 2 here. So the negative 2 here tells you that you are having a N shape. When we are having the N shape, if you have a look for the diagram, that means the highest point will be at the coordinate 3 over 2 and also 15 over 2. So your range below the maximum point, which is 15 over 2. Therefore, you can state the range here. So the range of the function f basically means that you should be having fx smaller or equals to 15 over 2. Why is it smaller equals to? It is because of this is the maximum point where the curve actually touch this maximum point. Alright, so the range should be smaller or equals to this value. Alright, then let's have a look for part B. Okay, so for part B, they are telling us that the function fx transform to the graph hx by a reflection in one of the axes followed by a translation. It is given that hx has a minimum point at the origin. Okay, so give the details of the reflection and translation involved. Okay, so now originally I'm having a maximum coordinate or maximum point for the function fx, which is 3 over 2 and also 15 over 2. So to get a minimum point, right, after the transformation, of course, we need to go through reflection. So when we go through the reflection, to change maximum become minimum, basically it is a reflection, up-down reflection, because maximum you want to change it become minimum. Okay, so it should be reflection in x-axis, which means that originally, if let's say you are having a graph like that, so now you want to reflect it become the graph something like this, something like that, right? Okay, maximum become minimum point, so you have to reflect it. So the reflection will be in the x-axis. When you reflect it, the value in the x-axis, right, the positive value for y will become negative. And now you're having a minimum point at this coordinate. Then how can I continue to get a minimum point at origin? How can I change it become origin? So you know that you need to involve a translation. You are moving the whole curve. Okay, so from 3 over 2 to 0, basically you have to move it negative 3 over 2, or you have to move it 3 over 2 unit to the left. Then from negative 15 over 2 to make it become 0, you have to move up 15 over 2. Alright, so basically this is what we have lah. So you should write it out again in detail. The first one, the reflection will be the reflection in x-axis. Followed by the translation. So the translation, what is the vector of the translation here? It will be negative 3 over 2 and also 15 over 2. Okay, so if you are not so sure, right, how to decide all these details, basically you can use the stationary point in the curve, right, to help you and decide. So from there, maybe you can see more clearer. Right, so like for me, I know that, oh, this is my maximum point. So to change it become minimum point, from there, I know that I have to apply reflection. Up-down reflection, which is the reflection in the x-axis. Then after that, I need to know I have to move the whole curve around so that I can get a minimum point, which is at 0, 0. So it involves the translation. Alright, so when we are having one particular coordinate to refer, right, it will be much more easier for you to visualize the whole thing. Okay? Alright, then let's have a look for part number C. Okay, for part number C, they define the function gx by this one. So try to have a look for the function gx and fx. Basically, the expression is the same. The only thing different is this one. Okay, the domain. The domain defined for the function. Okay, then now they want us to sketch the graph of y equals to gx and explain why g is a one-to-one function. So you are not required to find the coordinate of any intersection with the axis. Alright, so first of all, I want to sketch the gx first. Okay, so gx, the expression same as fx, right? Then just now when we apply, or maybe when we find out the completing square, this is what I get. 15 over 2 minus 2, then x minus 3 over 2, then square. If I try to figure out this particular graph, I'm having a maximum point at the point 3 over 2, and the maximum point is 15 over 2. So this is my maximum point here, and my graph is a N shape. Alright, and usually when we want to figure out clearer, right, my N shape, it will be good if we know what is the y intersection, the y-intercept. So if I substitute 0 into the equation, so my y-intersection basically is the 3. And of course, if you want, you can continue to find the root for the value for x or the x-intercept. But I don't think it's needed, right? So this is generally what we have for fx. But when we are talking about gx, we only want to refer, or we only want to consider the part of the graph where it is smaller equals to 0. So you can see from here, x equals to 0 means y equals to 3. So that means smaller than 0 means they only want us to consider this part of the graph in green color. So the whole red color here is my fx, and my green color graph here basically is the gx. Okay, so they want us to sketch this particular graph on the diagram. So we'll sketch it now in detail, right? Okay, so I'm having this axis. Okay, then just now I know that my curve start from 3. And then it will going down. Okay, it is a curve that is going down from the U shape. Right, so if you want, you can draw it bigger with a bigger scale, maybe like that. So maybe your curve looks something like that, right? Okay, then when you draw, maybe what you have here is something like this. Okay, right, so this is your gx. And how I know that it is a one-to-one function? Okay, so basically it is because of when you draw any horizontal line, when you draw any horizontal line, right, it will always have only one intersection point with the function gx at at a certain time, right? Okay, when you move up or down, right, the horizontal line, there's always one intersection point only can be seen. So you can just explain it in a simple way, where there's only one intersection point can be seen. When we apply the horizontal line test. Horizontal line test means that you draw a horizontal line and try to figure out how many intersection points at a time. Okay, so at every single time when you draw the horizontal line on gx, okay, you realize that there's always one intersection point only. Okay, so this is how we get the graph and also how to explain it. Then in part D, now they want you to sketch the graph of G inverse in your diagram. Find the expression for G inverse as well. Okay, so you need to sketch, you need to find the expression. Then they ask you to label the two graphs appropriately and show any relevant mirror line. Okay, let's talk about the G inverse first. Okay, for G inverse, we know that the inverse function and the original function will reflect each other at the line y equals to x. So maybe for the very first thing, right, what you can do is like maybe you can try to draw the line y equals to x first, because this is a mirror line. Okay, our original function and also the inverse function always reflect at y equals to x. Okay, so I label this clearly. This is y equals to x. And now if I want to sketch the gx, g inverse, sorry, we already have gx, right? If I want to sketch g inverse, basically you need to swap the x and y coordinate. So as an example, if let's say I'm having this one which is 0, 3, when I swap the equation, it will become 3, 0. Swap the coordinate, it will become 3, 0. That means for y, so for g inverse, I need to sketch one point at 3, 0. And after that, we also know that all the inverse function and the original function will intersect each other, okay, at the line y equals to x. So that means my inverse function will go through this particular point as well, because all of them intersect at the same point, right? Then you try to connect these two lines together or these 2 points together, then assume that the y equals to x is a mirror. So your final graph should look more or less like this. and we'll label this as G inverse. Okay, so this is how we complete the graph, right? So don't forget about the mirror line. This is the mirror line. Don't forget to label your G inverse and also the original function G. Then we're done for the sketching part, and now we want to find the expression for G inverse. Okay, since the function G is a quadratic equation, right? To find any quadratic equation, to find any inverse function in the quadratic equation, you need to always start with the completing square form. So this is the completing square form that I have. Okay, so to find the inverse function, I will let this equation equals to y. And I want to rephrase the equation become x equals to something something y, where that will be my inverse function. Okay, so we try to move it slowly. Okay, so by right, if you want to have x equals to something something y, right? Okay, I will move the 2 here. Okay, then I will be having 15 over 2 minus y. Okay, then I divide whole thing by a 2. Okay, I take the square root so that I can get rid of the square. Wait, okay, so I take square root. When I take square root by myself, I have to include both plus and minus sign. Okay, so next one, I will be having 3 over 2 plus minus square root 15 over 4 minus y over 2. Okay, so when I'm having x equals to something something y like this, basically this is my inverse function for the g. But here show us two possible answers. The first one basically is 3 over 2 plus square root something. Another one will be 3 over 2 minus square root something. Okay, so I cannot accept both answers as the inverse function. I can choose only one. So which one of this belongs to the correct inverse function? And again, we need to recall back one important result that we learned earlier. The range of the inverse function is equals to the domain of the function. So this is the equation of the range of the inverse function. So it relies on the domain of the original function. So your domain is smaller than 0, smaller or equals to 0. So now you ask yourself, from these two equations, which one will give you the result smaller or equals to 0? So when you're having 3 over 2 plus something, right, you will getting always bigger. The answer always bigger than 3 over 2. So this is not the answer that you want to accept. This is the possible answer that we have, because when you're having 3 over 2 minus something, it is possible for us to get something smaller than 0. So this is the correct function for the g. Okay, so you have to choose one, you cannot accept both in your solution. So the inverse function, if I write out properly, it will be 3 over 2 minus square root 15 over 4, okay, minus, change it become the x, so minus x over 2. Right, yeah, so this is basically how we solve this question 11 here. Alright, so this is the end of the video. Thank you very much for watching.